And in this problem, we want to synthesize 2-methyl propanol from 2-bromo-3-methyl butane. And so, as always, our first step would be drawing the structures and see what are the changes in the skeleton. So what is that we want to make? Propanol, that's an aldehyde. So that'll be my carbon 1. So 1, 2, and 3, 2-methyl propanol. So we have 3 carbon atoms. And now let's see what we have here. We have butane, and 1, 2, 3, and 4. And so it says 2-bromo, 3-methyl butane. And so what we see here is that we have less carbons. We have here a total 4, and here we have 5. So we need to have a strategy to cut this molecule and have it smaller. So to do that, we're going to do a different strategy then, which is we need to make a double bond so that later we can do ozonolysis and cleave that into fragments. So how do we do that? If we want to make an alkene, and notice that I'm keeping, let's highlight that. I'm keeping this carbon, let's see, I'm keeping that, but I want to make an aldehyde. What I want to do then is make a double bond. So if I need to make a double bond and then do an ozonolysis, I want to use a base that is large so that I have the Hoffman product. So I'm going to use TBU. Okay. So this is potassium tributoxide. Why is that? Because again, bulky bases will preferably are regioselective, and it will give you the Hoffman product. So you will do, this is an E2 elimination and E2, all right? So let's do one of the hydrogens. We can write the 3 actually. Well, let's do. So O negative here. We were gonna get this hydrogen. In concerted fashion, we are gonna make the alkene. So that is a terminal alkene. And again, we're using a bulky base to accomplish that. And this is the Hoffman product. If we didn't do that, let's see what would happen, which is not what we want. But what if we use instead sodium hydroxide? So remember that the small bases will favor the Sisa product. So you will do an elimination over here you have a hydrogen, so you will make a different alkene, and that's not what I want. Okay, so I don't want this path, so I'm gonna cross it. What I want is this. And why is that? Because I want to make that molecule, and now I want to cleave that molecule to make this aldehyde. So the way that we do that, if we're gonna do ozonolysis. So ozone in DMS, so dimethyl sulfide, PMS. All right, so what this is doing is we are cleaving this bond. And now notice, I will form 2 things. We're going to form formaldehyde plus this molecule above. So now I've reached my target. So yeah, we have learned now, before we did the strategies to add carbons to the chain, such as the alkylation of alkynes, terminal alkynes. Now we have a strategies again. This one is to cut carbons from the chain, make it smaller. So by making an alkene and then doing ozonolysis, we are creating a molecule that has less carbon atoms.